this class, we discussed regarding the third mode of propagation. Third mode of propagation. That is space wave or tropospheric, or it is also called as LOS. LOS means line of sight propagation. Line of sight propagation. Okay. So three names are there. So one is it may called as space wave or tropospheric or LOS, line of sight propagation. Okay. So as I have already told that by using this third mode propagation, that is tropospheric or line of sight propagation, I can transmit all signals whose frequency is greater than whose frequency is greater than 30 megahertz. 30 megahertz. So all frequencies greater than 30 megahertz. We are supposed to use third one, that is space or tropospheric or line of sight propagation. Okay, so see here, and what is the height above the Earth surface? It is extended up to 16 kilometers above the Earth surface. 16 kilometers above the Earth surface. Okay, so coming to the space wave propagation. So the space wave propagation is useful for higher frequencies. Okay, so this is useful for higher frequencies, that is VHF, VHF and microwave range. Because surface wave and sky wave propagation both fails at these frequencies. Okay, so that's why you're going for space wave propagation. Okay, but what are the limitations of space wave propagations? Limitations of space wave propagation. Space wave propagation. The limitations of space wave propagations are, the first one is it is limited by line of sight. It is limited by line of sight distance. And also the other one is it is limited by curvature of the earth. Curvature of the earth. Okay, so these are the two limitations. One is line of sight distance, the line of sight distance, and the other one is curvature of the earth. Okay, so what is meant by this line of sight distance? Okay, so line of sight distance is that distance between the transmitter and the receiver, in which if a direct ray passes, from the transmitter to the receiver, without being intercepted by the bulge in the earth surface, must see at least the top of receiving antenna. So this is the definition of line of sight. The line of sight distance is the distance between the transmitting and receiver, in which the direct ray passes from the transmitter to the receiver without being intercepted by the bulge in the earth surface and must at least see the top of receiving antenna. So let us see here. While discussing the introduction regarding this space wave or tropospheric wave propagation. So let us consider this is my transmitting antenna. This is my transmitting antenna, and this is my receiving antenna. Okay. So there are two ways to reach the signal from transmitting antenna to receiving antenna in uh, space wave or tropospheric. One is you can, that is by direct path. That is direct path. The signal reaches from transmitter to receiver. The signal reaches from transmitter to receiver by a direct path. So this is direct path. Direct path. Another path is the signal comes, touches the surface, get 180 degrees phase difference, and reaches. Okay. So this is another path. Okay. So this is path A. This is indirect path. This is indirect path. Okay. So if you observe here, this A, you will call it as line of sight propagation. Line of sight propagation. Okay. Or the distance between this transmitting antenna and receiving antenna, we call it as line of sight distance. Okay. So what is meant by this line of sight distance or line of sight propagation means, if you look at this transmitter, okay, so you should at least see the tip of the receiver. Should see the tip of the receiver. Okay, so sometimes, for example, if the transmitting antenna is like this and your receiving antenna is like this, you will see the direct ray. It is not possible to come to receiver because this direct ray is getting stopped by the bulge of the earth surface. Stopped by the bulge of the earth surface. Okay, so this is one limitation. So there are two paths for a signal to come from transmitter to receiver in LOCS or tropospheric is one is through direct path. Okay, so that is direct path. Another one is it touches the surface and get reflected back by 180 degrees and reaches to the receiver. So this is the second one is the indirect path. The first one is the direct path. The first one is the direct path. Okay. So now let us calculate.